Welcome. Displacement time graphs are the absolute foundation of kinematics. In Paper 1, they appear frequently as visual distractors, testing if you can instantly translate a shape into a physical motion. In Paper 2, calculating a gradient from one of these curves is often the very first step to unlocking a 10-mark mechanics problem. Let us secure those marks.
We begin with the most important rule for straight lines. A displacement time graph maps an object's position against time. The absolute golden rule here is that velocity is the gradient of this graph. If the line is straight, the gradient is constant, which means the velocity is constant. A horizontal line has zero gradient, so the object is stationary. A positive slope means it is moving in the positive direction. A negative slope means it is moving backwards, returning towards or passing the origin. Because velocity is the rate of change of displacement, we calculate it using the gradient formula, change in displacement divided by change in time. A straight line passes through 2 seconds 10 meters and 5 seconds 25 meters. A student calculates velocity by dividing 25 by 5 to get 5 meters per second. Why is this method dangerous? Pause and think. It only works if the line passes perfectly through the origin. If the object had a different starting position, dividing a single coordinate gives the wrong answer. Always use the change in displacement over the change in time.
When an object accelerates, the rules change. If velocity is changing, the gradient is changing, so the graph becomes a curve. To find the exact velocity at one specific moment, we need the instantaneous velocity. You find this by drawing a tangent to the curve at that exact time. The gradient of this straight tangent line is your instantaneous velocity. In the exam, use a clear ruler. Adjust it so the gap is symmetrical on both sides of the point and draw a long line to minimize reading errors. We need the gradient of the tangent, so we set up our change in displacement over change in time. Substitute the coordinates of the 2 points on the tangent line. Calculate the numerator and denominator, giving us exactly 4.0 meters per second. Notice we did not use the 3 seconds coordinate at all.
Now, let us contrast this with average velocity. What if you need the average velocity over a whole time interval? Average velocity ignores all the speeding up and slowing down in between. It depends entirely on total displacement divided by total time. Graphically, average velocity is the gradient of the chord, that is, the straight line drawn directly from your starting point on the curve to your finishing point. Confusing the tangent and the chord is a classic structured paper error. An object accelerates uniformly from rest, so its displacement time graph curves upwards. Will the average velocity between 0 and 4 seconds be greater than, less than, or equal to the instantaneous velocity at exactly 4 seconds? Pause and visualize the graph. The average velocity is less than the instantaneous velocity. The chord from the origin is less steep than the tangent at the very end of the interval, where the object is moving fastest.
Let us secure your marks against the most common examiner traps. First, the total time is 50 seconds. Next, the net displacement. They went 400 meters forward, then 200 meters back. The net displacement is positive 200 meters. Finally, divide the total displacement by the total time. The average velocity is exactly 4.0 meters per second. If the question asked for average speed, we would have added the distances to get 600 meters. Cambridge examiners set very predictable traps. The most devastating is confusing a displacement time graph with a velocity time graph. Always circle the y-axis label first. If you see a straight sloped line on a displacement graph, that is constant velocity. On a velocity graph, that same shape means constant acceleration.
Let us bring it all together. You can now interpret the gradient of a displacement time graph as velocity. You can extract instantaneous velocity by drawing a tangent and average velocity by drawing a chord. And you know to always check the y-axis label before you start calculating.